Hello again, chemistry students. So here's the thing. Sometimes balancing equations isn't as straightforward as the ones that we just did. So let's take a look at this question. What if there are polyatomic ions that are included in the compounds of the chemical equation? Now, could you simply take the elements out of the parentheses separately? Sure, but that will probably drive you crazy. My advice is to keep anything inside of the parentheses together and don't separate them out. Don't split them up. So let's take a look at our first question where we have calcium hydroxide being combined with beryllium nitride, and together they produce calcium nitride and beryllium hydroxide. So once again, the first thing that I want to do is create my grocery list. I want to count the atoms and the polyatomic ions. So remember, the polyatomic ions are like the OH that's inside this parentheses. So I'm going to start again because this is just where I'm most comfortable, all the way over to the left. So I have calcium. I'm going to keep my hydroxide in the parentheses. I have beryllium and I have nitrogen. I have one calcium. I have two hydroxides because I have a subscript of 2 on the outside of the parentheses. I have 3 berylliums and I have 2 nitrogens. Over on the other side, I have also calcium. I have hydroxide. I have beryllium and I have nitrogen. This time I have 3 calciums. I have 2 hydroxides. I have 1 beryllium and I have 2 nitrogen. Okay. So, like I said before, I just like to move from left to right. So if I look at my calcium on the reactant side, I have 1, and on the product side, I have 3. Well, what number times 1 will give me 3? The number 3. So I'm going to put a 3 coefficient in front of my calcium hydroxide, and 3 times 1 is 3. And I have 2 hydroxides, which I have written here. 3 times 2 is 6. Now let's take a look at my hydroxides on the product side. I have 6 on the reactant side. I have 2 on the product side. What number times 2 is going to give me 6? Well, that's the number 3, of course. So I'm going to draw a coefficient of 3 in front of the compound that has hydroxide in it. And 3 times beryllium, which is 1. 3 times 1 is 3. And 3 times 2, which is what I have written here in my grocery list, is 6. And now if I look at my numbers, I have 3 calciums on each side, 6 hydroxides on each side, 3 berylliums on each side, and 2 nitrogens on each side. So here I am all balanced. Let's try another one. So here, let's draw our line for our grocery list. I have barium. I have NO3 in parentheses, so I'm going to keep it together, NO3. I have aluminum. And in parentheses again, I have SO3. So you can see, like I'm not counting the oxygen separately. I'm counting the polyatomic ion as if it's its own element. So on this side, I have 1 barium, I have 2 nitrates, which is the name of the polyatomic NO3. I have 2 aluminums, and I have 3 sulfites, and that's the name of SO3. And if you want to find the names of your polyatomic ions, look on the back of your chem helper. That's where you're going to find them all. Also, if you're not sure if something is a polyatomic ion or not, you can always look at the back of your chem helper and look at that reference list and it'll tell you. Because look at this compound, BaSO3. Here's the thing about polyatomic ions. If there's only one polyatomic ion, you usually don't see parentheses. So knowing that SO3 is a polyatomic ion, I'm just going to draw my parentheses there. And now I'm going to write in all of my ions and atoms. Oh, there we go. And I do like to keep my polyatomic ions enclosed in the parentheses because it's kind of just like a good reminder that anything that's inside of the parentheses, like anything inside of a suitcase, goes together. Like you're not going to go to the airport and start taking stuff out of your suitcase. Keep all the things in the suitcase together. So my barium, I only have 1. Nitrate, I have 3. Because there's a little 3 on the outside of the parentheses. I'm not saying 3 because of the 3 inside of the parentheses. I'm saying 3 because what's on the outside of the parentheses. Aluminum has 1, and sulfite also has 1. Okay, so I'm going back to the left, but this time barium is balanced, so I don't have to do anything with barium. However, if you take a look at my nitrate, NO3, I have 2 on my reactant side and I have 3 on my product side. Well, gosh, 2 and 3, like there's nothing that I can multiply 2 by in order to get 3, and there's nothing that I can multiply 3 by in order to get 2. So what I am going to do instead is I want to figure out what is the least common multiple between 2 and 3. And to find that out, I just multiply 2 times 3, and that equals 6. So what I want to do, this is the lowest number that both 2 and 3 can divide into evenly. So what number times 2 will give me 6? Well, that number would be 3. So I'm going to draw a 3 in front of the compound that has nitrate in it. And what that does is it changes barium to 3 because 3 times 1 is 3, and it changes my nitrate to 6, which I'm writing in green there. Now let's look to my other side. Since I changed barium on my reactant side, I need to look and change barium on my product side. So again, I want to draw a coefficient in front of the compound that contains barium so that whatever number that is times 1 gives me 3, so that it will equal the reactant side. So of course that's going to be 3 again. That means that I now have 3 bariums, and 3 times 1 sulfite is also 3. Okay, so bariums are good, and my nitrates aren't quite right yet. Aluminums are not right, but my sulfites are. So let's see what I need to do to change my nitrates, my NO3s. Well, I have 6 NO3s on my reactant side. How do I get 6 NO3s on my product side? Well, what number times 3 will give me 6? That number is 2. So 2 times 3 is going to give me 6 NO3s, and 2 times 1 is going to give me 2 aluminums. Sorry, I accidentally erased my 1 there. So by adding these 3 coefficients, a 3 in front of barium nitrate, a 3 in front of barium sulfite, and a 2 in front of aluminum nitrate, I have balanced my equation. I have 3 bariums on each side, I have 6 nitrates on each side, 2 aluminums, and 2 sulfites. So you just have to remember to kind of keep your head, and when you are balancing, you are multiplying coefficients times subscripts. And remember to keep your polyatomic ions together. All right, last question. What do you do if there's water? Now remember that water has a formula of H2O. So what if you have water on one side of the arrow, but not on the other? Like, look at our equation. We have aluminum hydroxide, we have dihydrogen sulfide, on one side, and then we have water on the other. So what do we do with this? We have a polyatomic ion here, but not over on my product side. So what are we going to do? If you have water on one side and you have a hydrogen and a hydroxide on the other, the solution is very simple. Look at what we're going to do. We're going to rewrite water's formula so that, I'm just going to cross it out here, we're going to change it to H parentheses OH. So we're going to keep hydroxide inside the parentheses, treating it like a polyatomic ion, and now we have a hydrogen left outside. Now we can create our grocery list, and we will have the same ions and elements on each side. So on my reactant side, I have 1 aluminum, 3 hydroxides, 2 hydrogens, 1 sulfur. And on my product side, I have 2 aluminums, I have 1 hydroxide right over here, I have 1 hydrogen, and I have 3 sulfurs. So now, because we changed our water to HOH, it becomes a simple balancing exercise, just like the ones that we did at the top of this page. So here I have aluminum is 1 on my reactant side, and it's 2 on my product side. How do I get 2 on my reactant side? Well, I have to multiply some number times 1 to give me 2, and that number is 2. 2 times 1 gives me 2 aluminums now, and 2 times 3 hydroxides gives me 6 hydroxides. Now I need 6 hydroxides on my product side. 6 times 1 gives me 6 hydroxides and also 6 hydrogens. Now let's go back and look at my hydrogens on the reactant side. See how I'm bouncing back and forth? It's not linear. You got to do a little on one side and then go back and do a little on the other. What number times 2 is going to give me 6? Well, that number is 3, so I'm going to write 3 as my coefficient, and 3 times 2 is 6. But remember, the 3 is also going to change the other element in that compound, making the number of sulfurs 3. And look at what happens. 2 aluminums on each side, 6 hydroxides, 6 hydrogens, and 3 sulfurs on each side. So, hey, I am balanced. And I was able to do that because I rewrote the formula for water. Let me just go back and show you what it would look like if we did not rewrite the formula. So if we did not rewrite the formula for water and we were trying to make our grocery list, then we would have aluminum, we would have hydroxide, we would have hydrogen, and we would have sulfur. And if we went on this side, we would have aluminum, we would have sulfur, we would have hydrogen, and we would have oxygen, but oxygen and hydroxide are not the same. And so we would have a really difficult time balancing out this equation. So that's why by rewriting H2O as HOH, we now, on my product side, have exactly the same. So there's my aluminum, and here's my sulfur. Here's my OH, my hydroxide. We now have the same elements and polyatomic ions on the product side as we do on the reactant side. And then we can go forward and balance our equation. All right, that's it. I hope that this tutorial helped, and I'll see you in class. Bring your questions. Take care, chemistry students.